Welcome to this course, and we will meet every Monday and also Wednesday. Okay, my name is I-Fan Lin, and my office room is in the new mechanical engineering building. Okay, just next to the College of Engineering building, or you can say across the street of this building, in room 305. Okay, so if you have any questions, then send me the email. Make sure that every time when you send the email, your subtitle will be like ME 2001, okay? Because I will get a lot of emails every day. So I'm not sure that if you don't have a good subtitle or subject, then I probably will ignore that. And we also have our TA. So TA is now sitting in the back of the room. Just say hi to everyone. And his name is, introduce yourself briefly. Okay, thank you. And his office hour is Wednesday, right after our class. Okay? So if you have any questions, either ask me or ask TA. Okay? So for this course, you will learn what is the ordinary differential equation. And the most important of all is to find a solution of the ordinary differential equation. And how do you find the solution? We have different methods. So in this semester, we have 4 topics. The first is the ordinary differential equation to find a solution of that equation. And then you can also use other methods like the second topic, Laplace transform or series analysis to find the solution. And later on, you will learn the linear algebra because we will also use the linear algebra to find a solution. And later, the last topic, based on the knowledge of your linear algebra, we can solve the system ordinary differential equation. So overall, at the end of this semester, you will understand the mathematical tools, the common to engineers, and also you will solve the standard ordinary differential equations. And you know how to analyze that. And since we have the team homework, so you will also learn some applications of this math, okay? Because most of the time, people don't like math. They just learn how to solve, but they don't know how to apply. So in this case, in your homework, you will find the applications of what you have already learned, okay? And here's the textbook, okay? We use the O'Neill, this textbook, rather than the Zell, okay? You can buy the book contacting this person or contacting the student association, the Mechanical Engineering Student Association, or even you can find it online for free. Okay, and normally we will go through all the materials, but not all, okay? So it's based on my notes. So basically, if you just understand all the notes from my handout, and also you do the drills, then I think you will be okay in this course, okay? And here's the rubrics. Okay, for the rubrics, we have team collaboration. And for this team collaboration, every time, especially on Wednesday, you may do some, either on Monday, during the class, we may do some drills or some like a team competition, okay? So this time you need to have a really good team collaboration with your teammates, okay, to solve some questions. For this team, okay, you need to form a cultural team. And most 4 people, okay? For 4 people, you need at least 1 Taiwanese student. Okay, so I think later on you need to find your team. Okay, and once you find your team, in the NTU core we have a group list. You need to fill out your names and also your name and your student ID. Okay, And at the end of the semester, you will give your team member an evaluation from -5 to 5. Okay? Team quiz, 20%. Every Wednesday, we have a quiz. How many of you, or do you have class just right before this class? Raise your hand. No, sorry. On Wednesday. On Wednesday. Wednesday is 9 to 10, right? Right before 9 to 10, do you have any class? If you have class, raise your hand. No? Okay. So that's good. Then our quiz, it should be not 10 minutes. Okay, there'll be probably 10 to 20 minutes. Okay, from 9 to 9:20. Okay, on Wednesday, you have a team quiz. So in your team, you may solve, so far, probably 2 to 3 questions. Okay, you have 4 people, all right? So you need to solve these questions in 20 minutes. And these quizzes are closed book and also closed note. Okay, but you can discuss, right? For the team quiz, it doesn't mean that you only rely on your teammates. You need to show up, okay? If you are late, then your scores will not be counted, okay? So that's the team quiz. And we will have a team quiz next week, starting from next week, all right? And for the quiz, the questions are from our class materials, okay? Either from our examples or even from our drills. And the team homework, we have 4 topics in this semester. And in each topic, you will submit 1 homework assignment. Okay, for that homework assignment, you need to find at least 3 applications. Like for example, we are going to talk about our first topic, the ordinary differential equation. And there are so many applications using ordinary differential equations. For example, like the circuits. So it's your responsibility to find out some applications and write a report and submit as a team. Okay? And the midterms, we have 2 midterms and also 1 final. Okay? The midterm will be just right before the national holiday. So after that, you can celebrate your holiday and take a rest. Okay? And they are all on Wednesday. That means you only have 50 minutes or 1 hour to solve the questions. Okay? And the questions are really fun. If you have already taken some courses from me, then you know that our questions will be like true and false, which is more easier than the hands-on questions, and also multiple choice, and also some practical questions. Okay? Again, that will be closed book, closed notes, and also no calculators. We will provide you the table if it is needed. All right? And our final will be on December 16th. So make sure that you mark down those 3 important days, okay? Because the makeup exam will be very difficult. So for the final, again, it's on December 16th, and there will be 2 hours. They will cover almost all the materials that we have already done. Okay, and it is also closed book, closed notes, and you will see. Okay. So for the makeup exam, unless you have the serious or emergency, like serious illness, or you have to do the civil service, otherwise we do not accept any makeup exam. Okay, and also make sure that our final is December 16th. So don't book any flight tickets before celebrating your holiday, okay? So you need to take the final, then you can do whatever you want. If you cannot take the exam on these 3 important days, then the makeup exam would be like oral test or even the written-based test. Not sure, but at least you will know that will be more difficult. Okay, and not many people did a good job or the great job for the makeup exam. So make sure that you come to the exam on time. for the regrade policy, once the TA handed back your quizzes or your midterms, within 3 days, you need to write a form, request a form, okay, for the regrade. For your regrade, you need to write it down clearly that what questions you have and what points you think that you want to get back. For the regrade, it is like a gambling, a risk, okay? We will also check your entire papers. So once we found some mistakes that we didn't find before, then your points will be also taken off. Okay. So, any questions so far? No? Right, so for our office hour, here's our office hour policy. Actually, we welcome you to come to the office during the office hour, but this is not saying that you just bring your homework or bring your question that you haven't done before and come to the office hours, come to the office and ask these questions, because TA and I are not the tutors. Okay, you have to be ready. Okay, make sure that you have the questions you want to ask and come to the office asking TA or me. Not just come and sit down and then start doing your drills or doing your questions. Okay, you have to come and ask directly some specific questions. Okay, for example, here are some examples. I am confused about the topic in class, and can you help me? Okay, so sure, that we are happy to help you. But if you say that I have no idea about the how to work on the problem 5, for example, then you need to read the lecture notes first, or even the textbook, and then also you try to do it before. Okay, or you can consult or ask your classmates first, and then you come here and tell me that which process or which procedure you are stuck, then we can discuss. Okay. For number 3, okay, I have an alternative approach for the problem 5, and here's my answer. And then that's great. Then we can discuss about different methods to find this the solution. Okay. If you miss the class and you want me to tell you about what I have taught, since you missed the class, then it's your responsibility to catch up. So don't just come and ask me to explain or to teach you the whole class again. Okay, we may have a video recording, then you can watch. All right. So you can ask the lecture notes and seek some helps, and you can also report the academic dishonesty. If we find that actually, here, for the academic dishonesty, if you cheat on your exams or you copy the work from other teams when submitting your homework, then you'll get 0 credit. Okay, it's 0 tolerance for cheating. All right, you need to do your best. Okay. If you don't get the good grades on your first midterm, there is still a hope, right? You know that how you can change your behavior to prepare this course. Okay. So don't give up just for like a first failure. Okay. So here we will talk about the differential equations. For the differential equations, we will know the first order differential equation, second order differential equation, and we will use Laplace transform to find the solution of the differential equation. We will also use series solution to find the differential equation. And you will also build the fundamentals, the knowledge of the fundamentals of linear algebra and the matrices, because you will use this to solve the system differential equation. Okay? Any questions so far? All right. So if you don't have any questions, here are some advice. If you want to pass with the flying colors, okay, you need to attend the class. Okay, every time you attend the class, be active. If you have any questions, just raise your hand or just speak up. Okay, we can discuss. I cannot make sure that I will always answer the questions directly. If I don't know, then I probably will need to study and then tell you that next time. But you still need to speak up once you have questions. Okay? And also you ask questions in class, because maybe your questions are other people's questions, and don't be shy of that. Okay? Just asking questions that will help your classmates and also you. So you need to spend probably 2 to 3 hours outside the class, because you need to review the materials and also redo the drills. Then I think the exams are not that hard. Okay. So here's the tentative syllabus. Any questions so far? So as I said, that we have 4 topics in this semester. Okay, for those 4 topics, the first one is ordinary differential equation. So what is ordinary differential equation? And why do we need to learn this differential equation? Okay, so first, what is the differential equation? This equation actually contains one or more derivatives. So here, what is derivatives? That means the rate of change. Okay, and here are some examples. Y double prime minus Y prime, because those are derivatives. Okay, one or more derivatives. This is the differential equation. You can also write it down as another form. Okay, du over dt. This is also the derivative. Okay. And for the differential equation, this equation is like a model systems. For example, like in motion, like financial markets, or the circuits, or the physical, or even chemical or biological phenomenon. And here, if we have time in class, then we can talk more about that. If not, and then in your team homework, you need to find some applications using these methods. Okay. For the differential equation, we need to know the types of differential equation. We have 2: ordinary differential equation and also the partial differential equation. Okay. In this semester, we will address on ordinary differential equation. Next semester, we will talk about the partial differential equation. For the ordinary differential equation, that means the derivatives are only single independent variable. Okay, single independent variable. See these examples. I only have, for example, x or even t, only one. Okay, when I take the derivative, only one independent variable. That will be the ordinary differential equation. If we have more than one, like 2, here we have x, and also you take the derivatives with respect to y. Okay, at the same time, that will be the partial differential equation. Okay, or we call that is not the ordinary differential equation. Okay, so throughout this semester, we only focus on this. Okay. Once you have this equation, you want to find a solution, right? what is y. Okay, this semester and next semester in the engineering mathematics, we always try to find the solution of y. And how do we find the solution of y? For the derivatives, we have different notation. Okay, for those notation, you will see the Leibniz notation. It looks like dy over dx or d square y. You take the derivative twice or even 3 times. This is the Leibniz notation. You also have a prime notation. You can see like y prime, y double prime, or y triple prime. After three derivatives, we put the number for that. Okay, so y to the 4th means that I take the derivative 4 times. Another one is Newton's dot notation, like S double dot on top equals minus 32. Okay, that is the Newton's dot notation. When you take some physics, probably you will see this notation. Okay, and also that means we can also use the Leibniz notation. That means d squared s over, here the dummy variables, let's say t. T squared will be minus 32. All right. And the last notation is called a subscript notation. You will see that when we talk about the partial differential equation next semester. Okay, and u xx plus u yy, that's 0. Any questions for this? Okay. Next is the order of ordinary differential equation. So what is the order for the differential equation? Here we say that the order is the order of the highest derivative in the equation. When we need to distinguish or make sure that the order of the ordinary differential equation, we need to find the order of highest derivative. Okay, for example, in this case, what is the order? You need to check the highest derivative in the equation. So is this second order differential equation or third order differential equation? Anyone? Third? Why? Power of 3, right? It is called power of 3. Good. Is that the highest derivative? I want to find the highest derivative. So the highest derivative will be 2, right? This is just the power. Okay, but we just take the derivative twice. So it's called a second order differential equation. Second order differential equation. And we can also write it down. In this case, since it's second order, so I can say that this is d squared y dx squared equals f of x. Also, this is a function of x, y, and y prime. Okay. Like in the midterm, maybe that I will give you a true and false and tell you that this is the third order of differential equation. Then you need to tell me it is true or false. Or even there will be in the multiple choice. Okay. And why they put the downside? Okay. And how about this one? Is that the first order or second order or zero order? First, you can see that we have dx and dy. Okay, we can rearrange that. To rearrange this equation, okay, dy over dx plus the function m divided by the function n, that's 0. We can also think about this fraction as a function. Okay, so that will be dy over dx. That's the function of xy. Okay, apparently this is first order. Okay, this is the first order differential equation. Right, so far so good. Before we learn how to find a solution, we have some basic concepts. Like you need to know how to distinguish the types of the differential equation, and also here the order of differential equation. Next, you need to know what is linearity. Okay, so linearity, here is the equation. Okay, this equation is linear because first, here is the coefficient. Okay, the coefficient depend at most on the independent x. Okay, this coefficient is a function of your dummy variable. Okay, not y. If you put y here, that will be not linear. Okay, so maybe coefficients like this one here, and I will also put this, the constant coefficient. Okay. The second one is the power of each term will be 1. The power of each term is 1. If I have a square, cube, whatever to the fourth, then it is not linear. Okay, we won't say this equation is a linear equation. Why do we need to know this is linear or not? Because hopefully today or probably on Wednesday, you will learn that if you know that this is a linear differential equation, we have a method for finding the solution, specifically for the linear differential equation. If not, then we use other methods. Okay? Here is the example. Y double prime minus 2y prime plus y equals 0. First, is that linear? And second, what is the order of this ordering differential equation? Anyone? The order, and also, is that linear or not? Any guess? You can either raise your hand or probably just speak up loudly. This is the second order linear differential equation, right? Because first, the highest derivative is 2. Okay, that's second order. And this is linear because the coefficients are just constant. We can also say that it depends on the independent x, but it's just constant. And each power is 1, each term. The power of each term is 1. So this is the second order differential equation. And the next one, how about this equation? Is that linear or not? Non-linear, right? Because we have y for our coefficient. So this is the coefficient. And it is not, it doesn't depend on the independent of x or the dummy variable. The dummy variable. So this is nonlinear. And how about here? D squared y dx squared plus y squared equals 0. Linear or non-linear? Non-linear, because I have y squared. What order? Second order, right? Second order, but nonlinear differential equation. Okay, so because this is the power. So those two examples are nonlinear. Okay. Yes.
How would you know that the coefficient is dependent on x when y itself is a function of x? Y is not.
You can think about this is like y prime. Y prime could be dy over dt, dy over whatever, dx, dy over dz, just like a dummy variable. Okay. And then next, we are going to talk about the solutions. That is our interest. Okay. Throughout this semester and also the next semester, when you take the advanced engineering mathematics, we want to know the solution. And most of the time, you don't know the solution. And you do that by try and error. But at least we have, well, from past, have already found some useful methods to find the solutions based on some specific equations. Okay? So since we know how to distinguish the type of the differential equation and also how to know the order of the differential equation and whether the equation is linear or not, next let's talk about the solution of the ordinary differential equation. Okay. For the solution, we have two parts. The first part is called the particular solution, and the second part is the general solution. What is the particular solution? That means my differential equation followed by the initial condition. Okay. If I have an initial condition, then that solution is particular solution. For example, dy over dx equals 2. Oh, now I can see that from your calculus. Okay, the basic calculus, you will know that the solution is y equals 2x plus a constant c, right? So what is c? I don't know the c so far, but if I give you the initial condition, say the initial condition y1 equals 3. Then we can get the c, the constant c. Okay, 3 equals 2 times 1 plus c. So c is 1. And then we say that the particular solution y equals 2x plus 1. If I don't have the initial condition, then the solution is called the general solution. Y double prime plus, let's see the second order differential equation here. And we will learn how to find a solution for this equation, okay? So later on you will know the solution here is C1 e to the minus x plus another constant C2 times e to the minus 2x. This will be the general solution. Okay? And for the general solution, it really depends on this constant, well, the coefficients, C, C1, and C2, right? If I have a different C, then the solution will be different. Okay, so here is the interval curve that will plot the general solution. For example, in this case, y equals 2x plus c. So y equals 2x plus c. It is a line. Okay, so it should be a line. Oh, here's y. This is y equals 2x plus c. So your solution could be this line, could be the second line or this line. Okay, it depends on your c. For the second order differential equation, we can also plot your solution could be this is y equals c1 e to the minus x plus c2 e to the minus 2x. So if it is the second order, then I need two initial conditions to determine the coefficients c1 and c2. Okay. So in the textbook, they mentioned the initial value problem. They just give you the equation and then their initial conditions. And once you have initial conditions, you can point out your specific solutions. And here is the example. dy over dx, the first order differential equation with y of x naught equals y naught. And then the second derivatives, then I have two conditions. X naught with the associated y naught, and also x naught. When I take the derivative, then I have another value. So suppose my here. As I said, that this could be your solution. And this is your x naught, y naught. Once you have the initial conditions, you are bounded to this curve. This curve will be your only solution. Okay. Any questions? Now let's really solve the ordinary differential equation. Okay. So here is the procedure. First, you need to verify if this function satisfies the ordinary differential equation. If it is partial differential equation, then we use different methods to find a solution. And that will be mentioned in the next semester. Okay. And also, you need to verify it. And you need to see that if they have the initial conditions. For example, y prime equals y squared e to the minus x. And I give you the initial condition. Okay, first tell me that this differential equation, which order, and also linear or nonlinear. First order, nonlinear, right? Because I have a y squared, so it's nonlinear. But even though it is nonlinear, we can still find the solution. As I said that when we learn the linearity, that means that if we can know this equation is linear, and we use the specific method to find a solution, or some effective way to find a solution. If not, then we just either do it by our experience or just by luck. Okay, here you can get the y is 1 over e to the minus x plus 1 over 4th minus e to the minus 1. Okay. And for our first topic, which is the ordinary differential equation, we will focus on the first order differential equation. The second order ordinary differential equation. And we may talk about the highest order differential equation, but that will be based on the knowledge of the first order and the second order. So once you know that knowledge, then it is easier for you to extend the concepts to solve the highest order differential equation. Okay. So first, let's see the first order ordinary differential equation. And again, that we have many types. If you can distinguish that type, you can get the answer directly and quickly. First, we are going to introduce is the separable ordinary differential equation. So what is separable differential equation? You can see that the equation will be y prime equals two functions, or the product of functions, g of x times h of y. So in this case, this is the product of a function of x and a function of y. You can rewrite the y prime into like dy over dx. Different notation, okay? So if you have this form, then we call it is separable. Okay, this equation is separable. And this equation is called the separable differential equation. Since it is separable, what's the benefit for that for this separable differential equation? If we put the dx to the right hand side, you have dy equals gx h of y dx. Separable means that I need to separate two variables or two symbols. Okay, so now I put OY to the, for example, the left hand side, OX to the right hand side. Okay, so that will be 1 over h of y dy. That's equal to g of x dx. Right? So I separate the equation. Then you take the integration. Once you take the integration, that gives you the left hand side, 1 over the left hand side, this is the integration with respect to y. So, and here is the function of y. We can write it down. This is the antiderivatives. Here are the antiderivatives. And then you get the solution of y in a closed form. Okay. Let's just use our previous example. dy over dx is y squared times e to the minus x. We need to check if it is separable or not. And you see that here is the function of x times the function of y. So it could be separate, right? So if we separate, we have 1 over y squared dy, and the right hand side, e to the minus x dx, into the integration. Okay? So from the calculus, 1 over y squared, if you take the integration of 1 over y squared, you get minus 1 over y. Right? That'll be equal to e to the minus x plus the constant c. That's why you have 1 over e to the minus x. Okay, and here it depends on your initial condition. Right, so we have our solution, and there will be a general solution. 1 over e to the minus x plus c. Any questions so far? In this example, well, most of the time, for finding the solution of the differential equation, you can guess. Okay, if I don't tell you this, do you know the answer for that? At least one answer for y. What if y equals 0? If y is 0, that satisfies this equation, right? Because y is 0, then the right hand side is 0, and dy over dx, because y is 0, then 0. So actually, y equals 0 is also a solution. of the general differential equation. But once we use this separable ODE to find a solution here, we cannot get any C that this y equals 0, right? Because it's in the denominator, okay? If I get 0, there should be infinity. So but we can't. This can be obtained from the general solution. For any choice of C. But y equals 0 is the solution. So we call that y equals 0 is singular solution. Okay. If you don't have any questions, then here's another note. For this general solution, if I have the initial condition, like the initial condition y of 0 equals 4, then we can get your constant C is 3 over 4. So overall, your y is 1 divided by e to the minus x plus 3 over 4. And here, since our initial condition is different, 1 over 1 equals 4. So here's my C. And this is different. Okay? Any questions so far? Next one. X squared times dy over dx equals 1 plus y. Let's see if we can separate these two terms or not, two functions or not. So first, to check this equation is separable or not, we try to put everything of y in one side and the rest on the other side. So in this case, if we put everything belonging to y to the left-hand side, we have 1 divided by 1 plus y dy. And then x will be on the right-hand side, 1 over x squared dx. And here we have additional condition that to get the solution, okay, to integrate that, we need y is not equal to minus 1 and x is not equal to 0. In this case, when we take the integration, natural log 1 plus y will be equal to minus 1 over x plus c. And 1 plus y will be e to the minus 1 over x plus c. e to the c, e to the 5, e to the 6, e to the 7, that's a constant, right? So let me rewrite that. There'll be a times e to the minus 1 over x. Okay. And take the absolute out, then we have 1 plus y equals plus minus a times e to the minus 1 over x. Well, it's either plus 1, minus 1, plus 2, minus 2. So it's like a b times e to the minus 1 over x. And here b is non-zero. Okay, and then this is a general solution. In this case, y couldn't be minus 1. Okay. But if y is minus 1, you bring it back to this equation, it also satisfied. So however, y equals minus 1 is the solution. But in our general expression here, okay, here we have y equals minus 1 plus b e to the minus 1 over x. And we say that b is non-zero. Well, first, you may see that, okay, y equals minus 1 is a solution, but it is not in the general form. So this is the singular solution, right, as we said in the previous example. But in this case, we can also rearrange this coefficient b, okay? So in this case, it's minus 1 plus, say, like d times e to the minus 1 over x. And this d is not just non-zero. There will be any real number. D will be any real number. So in that case, y equals minus 1 is included in this expression. And this is our general solution. So this is general solution. And therefore, we say that y equals minus 1 is not a singular solution because we can use the general solution to include that specific number, y equals minus 1. Not a singular solution. Okay. Now, let's talk about linear ordinary differential equation. So what is linear ordinary differential equation? If I have the differential equation in this form, what is linear? How do I know that the differential equation is linear or not? What are the criteria? If the equation is linear, how do you know that this is linear? Yes.
Coefficients depend at most on the independent x.
And then?
And I don't know about the other ones.
Okay, good. Okay, what is the other criteria? Yes.
Power of each term is 1.
Okay, yeah, the other criteria, we have two criteria, right? The first one is that the coefficients only depends on one, while the independent variable. And the other one is the power, all the power is 1. Okay, so now we have this linear ordinary differential equation. You see that the coefficient depends on x only, and the term, the power is always 1. So for this linear ordinary differential equation, we say that if q is 0, this is homogeneous linear ordinary differential equation. If q is not 0, then it is non-homogeneous. If this is 0, okay, you see dy dx plus p xy equals 0. dy dx equals minus p of x y, and 1 over y dy equals minus px dx, right? So this is separable, right? So I have a product of one function and also the product of another function. So in this case, when q is 0, that is separable. That is also separable ordinary differential equation. So also separable. Okay, but if not, then we are trying to figure out how do we find a solution. Okay, so first we have this original equation here, right? And then for this original equation, I just times a common factor, common term. Okay, that common term is the exponential to the integration of a px. Okay, if I times this from both sides, then we can rewrite this equation. The left-hand side, okay, from the left-hand side, it's like after using the chain rule, we can get this result. So that is y over x exponential to the integration px dx. Right? By the chain rule, you take the derivative of the first term and keep the second term. And then you keep the first term. You take the derivative of the second term. And for the derivative of the second term, you also have a chain rule. Okay? So you get the px here, and then the original form. All right? Any questions so far? Like someone who was really smart in the past, they figure out, oh, if I times this term, okay, and this will be called integrating factor. If I time this integrating factor, then I can combine these two terms into one, because when I use using the chain rule, I will get back. Okay. The right hand side, well, for the chain rule, okay, I have two parts. So first, I take the derivative and keep the second part. And then I keep the first term, and I take the derivative of the second part. When I take the derivative of the second part, e to the x, if I take the derivative, that'll be e to the x, right? So that's why we still have the same form, but since here we have the function of x, another chain rule. For example, e to the x squared. There'll be e to the x squared, but here I need a chain rule, so I have 2x here. So that's why we have a px here. Right? So the right hand side, keep it, just copy it so far. Now, since it is we can take the integration, okay? If we take the integration, now what happens? Integration dx. Then we have the whole part, the y of x e to the integrating, times the integrating factor. And the right hand side, so I take the integration, your qx e to the integrating factor dx plus c. Okay? Imagine that this is just like an exponential. Okay, so suppose it's exponential to the x. Okay, and then I can get the solution y, because if I have a y times x, e to the x equals something, then the y will be e to the minus x times something. Right? So now I can get the solution y. The y will be so put here e to the minus px dx times qx e to the integration of px dx, and here I have e to the okay, that's the final form. Okay, so suppose yx times e to the x equals c. Then yx is c times e to the minus x. Right? And we call the purple term integrating factor. Okay, so integrating factor is e to the integration over px. So if you know that this ordinary differential equation is linear, then what do you do next? Finding the integrating factor. Once you find the integrating factor, then you can simplify the original differential equation and you'll get a solution right away. Okay? Okay, so now we know this integrating factor, then we will use that right away. Well, to use that right away, let's see this example. I'm not sure that if we can use that or not, because we have to identify this is linear. If it is linear, then yeah, we definitely can use. So is that linear? The coefficients depends on the x, and all the terms, the power is 1. Okay, so it is linear. So if it is linear, you can go, well, for the first few times, it's better for you to just do it step by step, okay? Follow this concept. So first you need to compare what is the P and what is Q. So here the P is, what is the P? 1. And what is the Q? Sine x. And since Qx is not 0, so it is not separable. Right? Remember that if it is 0, then it's separable. If it is separable, then use what we have learned on Monday. And if it is separable, that's quite easier. Once you learn more methods, you will see that this is the easier one. Okay, but you know that life is not easier. Okay, most of the time, you cannot get the separable differential equation. Then since it is linear, then we need the integrating factor. The integrating factor we know integrating factor is e to the integration of px. Okay, so there will be e to the 1 dx. That's e to the x. So once we have integrating factor, then we times this integrating factor to the original differential equation. So dy dx times e to the x, and then also y times e to the x equals, here I also have sine, and I need to time ex, e to the x. Okay. Remember that, why do we need an integrating factor? Once we have an integrating factor, yeah, on the left-hand side, this two terms can be compressed into one, right? Using the chain rule. How do I use the chain rule to get this result for two terms? D over dx. Okay, so here will be y times e to the x. Let's have a double check. Okay, when I take the derivative, two terms, remember this y is a function of x. So I have 2x here, two functions. I take the derivative for the first term, keep the second term, and then I keep the first term, take the derivative of the second term. And since it is exponential, when I take the derivative, it is still the same. Okay? Then right hand side, there'll be sine x e to the x. And then we have y times, well, take the integration, y times e to the x equals, again, you take the integration, sine x e to the x dx plus c. Well, I have a sine x and e to the x integration by parts. Okay. So you will use a lot of basic skills of the calculus. By taking the integration by parts, you have maybe here 1/2 e to the x sine x minus cosine x plus c. Okay. Make sure that you know how to get the final answer. Okay. Just one more step. If you don't know how to do that, ask your teammates first. And if you still couldn't know that, then just ask T or me. All right? Questions? Now, let's do one more example and practice. First, is that linear or not? Linear, right? Because the coefficients depends on x, and then the highest term, the power, is still 1. And this time we have initial condition, so we won't have this coefficient c. That initial condition will determine the constant c. So first, compare to our form of linear ordering differential equation. The px is, what is the px? 1 over x or minus 1 over x? 1 over x, right? And how about the qx? That'll be 3x squared. So if you are not familiar with this method, every time just follow like this step by step, finding the integrating factor first. Integrating factor e to the px dx. That's e to the 1 over x dx. So this is e to the natural log of x. That's x. And this x is greater than 0. Now, once we have this integrating factor, so I times the integrating factor to the differential equation. So here I have x plus y over x times the integrating factor, and 3x squared times the integrating factor x. So the left-hand side, we have xy that equals 3x cubed. Okay. So y is, or we say y of x, is 3 over 4 x cubed plus c over x. And then we take the initial condition to get the constant c. So therefore, our solution is 3/4 x cubed plus 17 over 4x. Any questions for this one? Yes.
Usually, if we take the integral of 1 over x dx, that turns out to be the natural log of the absolute value of x, which means that x can be both positive or negative. But why is it that in this case we can just consider x, or we can just take x to be positive?
That's why here I say that x is greater than 0. If x is less than 0, well, so you mean that it should be like plus minus x, right?
Yeah, something like that. Because in 1 over x, x can be both positive and negative. And so the integral should also reflect that usually. And that's why we have the absolute value. But in this case,
I know. I think you can put a plus or minus, because here I just also say that this x is only greater than 0, probably specific for some problems or issues. I mean the real issues, real problem. that they only need x is greater than 0. But in general, yeah, you can be like plus minus x.
Okay, thank you.
Okay, I will also upload the answer next week, okay, for the old drills. All right. You should get, I think the first one is x cubed 2 natural log of x. Whoops, x cubed 2 natural log of x plus c. And this number 3 should be 2/3 e to the 4x minus 11/3 e to the x. Okay. All right. Before class dismissed, let's do one more method to find a solution. Okay. So far, we have separable differential equation and also linear differential equation, and we know how to solve or how to find a solution, right? Next, you will see the exact differential equation. And what is exact differential equation? First, we call this phi of xy. This term, phi of xy, is a potential function for the differential equation. See, here is a potential function. Okay? For this potential function, if my differential equation is in this form, okay, and then they satisfied this partial differential equation, okay, this potential function divided by partial x is the m of the m of xy, and partial potential function over partial y equals n of xy. If they can satisfy this equation, we will say the solution is the potential function equals c. Okay. So once we can find this potential function satisfying this criteria, then the solution is potential function equals c. Remember, the phi of xy is just a function, not the solution. The solution will be the potential function equals the constant c. Okay. Then we will also say that this ordering differential equation is exact. So here's the theory. We say this differential equation is exact if and only if they satisfy this equation. Okay, partial m over partial y equals partial n over partial x. We can do halfway through. So first, let's see this example. Okay, this is the differential equation. Now, I think it's not separable, definitely, right? And probably not linear, since we have cosine, sine. So it is not linear, not separable. Then next, we can check if it is exact or not. To check exact or not, first we need to match the function of m and n. So the function of m is minus 2x minus e to the x sine y. And the n is e to the x cosine y minus plus 1. And we want to find the potential function. If we can find potential function, then the solution is the potential function equals a constant. So suppose we have m and n, those two functions. If I have a potential function, then the potential function, partial potential function of partial x should be m. So this should be m. Okay. And the second term, this should be n. No, this n should be equal to partial potential function over partial y. Okay. And we need to check if this really satisfies. Okay. Any questions? So next Monday we will verify it, okay, to see if it is exact. If it is exact, they can really satisfy these two equations, then the solution is just the potential function. And what we're going to do is to find the potential function, okay?